Welcome to Samvaad-Talks. Today we have the last talk in the theme A Roadmap to 5G and Beyond Communication. Today's talk is going to be delivered by Professor V. Sridhar, and the talk is titled Analysis of Radio Spectrum, Pricing for Commercial Mobile Services, a cross-country study. Today, the session is going to be chaired by Mr. Arvind Upreti, who is a PhD student at IIIT-Bangalore. Arvind has research interests in societal and labor market impact of technological change and adoption and implications of AI systems. He has a BTech in mechanical engineering and MTech in software systems and prior work experience at Infosys and Tata Motors. So we welcome both Arvind and Professor Sridhar for today's session. And we welcome all the participants here. We'll at both the Zoom meeting as well as on YouTube live streaming. We would like to request all of you to give your questions on the chat in the chat box as the talk progresses. So the stage is Arvind's for now. Yeah, thank you.
Thank you. And I welcome everyone to today's Samvaad-Talk by Professor V. Sridhar on analysis of radio spectrum pricing for commercial mobile services, a cross-country study. Dr. V. Sridhar is professor at the Center of IT and Public Policy at the International Institute of Information Technology, Bangalore. He's the author of 3 books: The Telecom Revolution in India, Technology, Regulation and Policy, published in 2012, The Dynamics of Spectrum Management, Legacy, Technology and Economics, published in 2014, and Emerging ICT Policies and Regulations, Roadmap to Digital Economies, published in 2019. His currently edited book titled Data-Centric Living, Algorithms, Digitization and Regulation is scheduled for publication in 2022 by Routledge. Dr. Sridhar has taught at many institutions in the USA, Finland, New Zealand, and India. He has received funding from different sources, both national and international, for his research projects, recent ones being from Facebook. He has been a member of Government of India committees on telecom and IT and has published many peer-reviewed articles in telecom and information systems journals. He has also written more than 300 articles in newspapers and magazines on telecom regulation in India. Dr. Sridhar has a PhD from University of Iowa, USA. I now welcome Dr. Sridhar to enlighten us with this talk.
Thank you very much, Arvind, and thanks very much, Professor Jaya, for inviting me for the Samvaad talk. So this particular talk, I'm glad to give this particular talk. It is an opportune moment for me to, give this talk. This work is, of course, co-authored with Dr. Rohit Prasad, the professor at MDI Gurgaon. I invited him to join this particular session. I hope he is there. Rohit, are you there?
I'm there, Sridhar.
Oh, good. Then all the questions on economics can be directed towards him. So Rohit is there. I work very closely with him. In fact, the 2014 book on spectrum management was co-authored with Rohit. Now, before beginning this particular talk, we would like to acknowledge Doticon, the British consulting firm, for sharing with us these wonderful spectrum database. We are really very fortunate to have an association with the Doticon for this particular work. And this work is also partially supported in funding by the Indian Institute of Management, IDEA Telecom Center of Excellence. So with this, we'll start. So we must have seen this, right? So there's an auction which takes place on the radio spectrum. You can see VIBGYR here. And then this is the pot of gold, and the auctioneer is very happy to have this pot of gold, right? And these are the poor bidders who have this, suitcase full of money, which they have given for acquiring this precious, scarce radio spectrum for providing commercial mobile services through their network. And you must have seen this particular numbers here. For example, there's a number followed by many zeros. In fact, there is a new denomination called lakhs of crores, which was invented in 2011. We are basically talking about money in lakhs and lakhs of crores in auctions. So it is very, very important from the country's point of view to understand how the auction takes place of the radio spectrum. Now, spectrum has been a cash cow for the government. In fact, I know that this is being telecast on YouTube, but still I would like to say this, right? In India since 2010, the radio spectrum auction has yielded this number, right? Number followed by many zeros, closely about $50 billion to the government of India exchequer. The recent one being the one which was conducted February-March 2021, which yielded something like this to the government of India exchequer, right? Close to around $12 billion. So there's huge money which is involved in the spectrum auction. In fact, that's not the only case, in India. For example, in the US, the first ever auction took place in 1994, which yielded about $1 billion, right? Subsequently, there were many auctions which were held in the US. The largest one being in 2014, that's called Auction 97, for the award of the Advanced Wireless Services Spectrum, the 1700 and 2100 megahertz, which yielded about $42 billion to the US Federal Communication Commission. In fact, 2018 auction, which was auction 73 on 700 megahertz, also yielded about $17 billion to the FCC. In the Europe, for example, in Germany, the 3G auction, which held in 2000, yielded about $50 billion to the government exchequer. So we are talking about many countries doing spectrum auction for huge amounts of money to the government exchequer. There are also some quickie auctions, right? So for example, in 2015, in Poland, the auction for allocating 800 megahertz and 2600 megahertz went on for more than 8 months, right? With a final round number 513, we will go into details of this round, what it means and so on, yielding a revenue of close to about 2.2 billion euros. In 2016 and 2021 in India, spectrum, there is also another quickie auction. For example, what is an auction? There are a set of items which are put on sale by the auctioneer, and then there are bidders who acquire these particular items at certain price, right? In 2016 and 2021 in India, some of the items, for example, the 700 megahertz which was put on sale went unsold, which means that nobody wanted to get this particular spectrum which was put on block. Okay? So these are all quirky auctions. So there are auctions which yielded huge amount of money to the government exchequer, and there are auctions in which the items which were put on sale went unsold. There were auctions which went on for days together, months together, and so on, right? So this is the characteristic of the auction that we will discuss about. Of course, any talk on auction is not complete without mentioning Professor Robert Wilson and Professor Paul Milgrom, who received the 2020 Nobel Prize for Economics Sciences for their contribution to auction design. In fact, this duo, along with McAfee, in 1994, suggested to the US Federal Communication Commission to conduct the simultaneous multiple round ascending auction for the sale of radio spectrum for personal communication services. And that's what we will discuss in detail later today. Now, so we know the broad concept of an auction. So there is an auctioneer. There are certain items which were put on sale by the auctioneer. There are bidders who have shown some interest in buying these items, and they bid, right? And there is a mechanism design, which of course invented by these Nobel laureates, and the process continues according to the mechanism design. And at the end, there are winners, and these winners pick up this particular item which was put on sale for the price that they have quoted. And this price goes to the auctioneer, right? In general, the radio spectrum is basically present to ether, and therefore it is a national property, and therefore the auctioneer holds the property rights, and more they are basically the state, right? The state owns this particular spectrum, And I must tell you one more thing. This radio spectrum is scarce resource, right? It is scarce. It is not available in plenty. Only certain amount of spectrum is available for certain users, such as, for example, commercial mobile services. And therefore, this scarce spectrum is normally owned by the state, and they are put for auction by the state, right? And therefore, the money which comes out of the auction goes to the government exchequer. I must also tell you one more thing about radio spectrum. The radio spectrum cannot be stored, right? So like water, it cannot be stored. So which means that this minute, if you don't use the radio spectrum, then it is wasted, right? It goes waste. And therefore, the unused or underused case of radio spectrum also needs certain considerations, right? Now, this picture looks quite complex, but this summarizes the whole concept of radio spectrum management. Right? So in general, we have this radio spectrum. Arvind, in case there are any pressing questions, I can always answer, right? So otherwise, I'll take the questions at the end.
Sure.
So the radio spectrum are broadly classified into licensed and unlicensed. And in the licensed, we will only talk about licensed, right? The unlicensed spectrum is mainly the one which is shared as a public good, and therefore it is not priced, and therefore it is not of interest to economics. And therefore, we will consider only the licensed spectrum in this particular talk. So the licensed spectrum in general consists of broadly, in the case of commercial mobile services, consists of three bands. One is what is known as the sub-gigahertz band. So the frequency spectrum which is less than 1 gigahertz, normally the 450 megahertz, 700 megahertz, 800, 900 megahertz, which are used for commercial mobile services, belong to this particular category. Then there is a mid band, right, between 1 gigahertz and 5 gigahertz. The popular bands in the spectrum in this band include 1700, 1800, 1900, 2100, 2300, 2500, 2600, and 3400 megahertz. So these all belong to the mid band. And then there is the millimeter wave, right? That is having frequencies above 5 gigahertz. Normally, the 26 gigahertz band and the 60 gigahertz band are the ones which are of importance. In fact, these specific bands are normally called as 5G bands, even though 5G can also be provided across mid-band as well as the sub-gigahertz band. So we will be talking about this portion of the radio spectrum in this particular talk. Now, when the spectrum is allocated, it can be provided for access, or it can also be provided for backhaul, right? Access is from your mobile phone to the telecom tower, right? Node B or the base transceiver station. So in this particular talk, we will be constraining ourselves to talk about access spectrum and not the backhaul spectrum, which is for connecting, for example, the BTS to BTS or BTS to, for example, the network center and so on. Spatially, the spectrum can be present. Of course, it is present everywhere, but it can be allocated nationwide, or it can be allocated on a regional basis, right? So, for example, in India, we use a regional-based allocation. For example, Karnataka, the state of Karnataka, there are about 22 service areas in our country, and we allocated regionally. Whereas small countries like the European countries like France, Germany, they all use it on a national basis. In fact, there are only 3 or 4 countries which allocate radio spectrum to the telecom operators regionally. In fact, India is one, China is the other, but China, we won't talk about China at all in this particular talk, because the method of spectrum allocation is very different, and all the companies, the telecom operators are state-owned enterprises. So we'll not talk about that. We'll only talk about market-based mechanisms which are present in, for example, India, the US, and the regional spectrum allocation is also present in Australia and Canada to some extent. We'll talk about both regional as well as national allocation in this particular talk. Then, with respect to the licensing methodology, right? How are they allocated? The spectrum has to be allocated, right? So, the spectrum is a scarce resource. Only this many, parts, this much of spectrum is available, but there can be many people standing in the line in order to get this particular scarce spectrum, and therefore there has to be a methodology, right? The methodology that we will talk in this particular course, in this particular session, is auction, right? So auction is one of the mechanisms, but the spectrum can also be sold for a fixed price. right? And India did it in certain occasions. And there is also a method which is normally very much used in the Nordic countries, which is known as beauty parade. Basically, you don't charge any fee, but you give the spectrum to an operator who deserves the most, right? Who has a lot of credibility, and that's why it's called as beauty parade method. Most of the Nordic countries, especially Finland, has been using beauty parade for spectrum allocation for quite some time. But in this talk, we will concentrate on auction, and auction is one in which the bidders bid for this particular item which is put on sale, and normally it can be a single round, in which case the highest bidder or the second highest bidder, depending upon the mechanism, right, gets the particular item. It can also go on for multiple rounds, right? It can go on like at one stage and then second stage, third stage, and so on and so on. We will be basically talking about the multiple round auction. Normally the auctions are ascending. There can also be ascending auction is normally called as English auction. There can also be descending auction, in which the price actually comes down, right? That's known as Dutch auction, which is used for example, the flower auction in Netherlands, for example, right? We will not be talking about descending auction. We'll be talking about ascending auction in this particular case. That is, the price only keeps increasing or remains the same and does not decrease in the successive rounds of the auction. There are also many types of ascending auction, which are multiple round, like cumulative clock auction or packaged auction and so on. But we will be talking about simultaneous multiple round ascending auction. The reason is that it is used in many countries, and it is almost a de facto standard until now, right, for allocating spectrum in different countries. So let's just talk a little bit about what is simultaneous multiple round ascending auction. Right? So here, multiple items, right? Multiple items. For example, there can be different spectrum bands: 700 megahertz, 1800 megahertz, and 26 gigahertz, for example. Or license service areas. For example, there's a spectrum to be allocated in Karnataka. There's spectrum to be allocated in for example, Tamil Nadu and Delhi and Kerala and so on. So the item is defined across, for example, the spectrum bands and the license service areas. And they are all auctioned simultaneously, which means that you don't have to wait for the Delhi auction to get over before starting the Karnataka auction, right? Karnataka and Delhi goes for like polls, right? They go for auctions together. And the 700 megahertz, 800 megahertz, or all these spectrum bands that I mentioned before can be put into auction at the same time, right? And they are all bid simultaneously. And these constitutes what is known as an item across the spectrum bands and license service areas. They are auctioned simultaneously, hence the name simultaneous. The minimum, the bidders simultaneously submit bids for each auctioned item, right? There are many bidders who submit bids on, basically indicating how much they are willing to pay for acquiring this particular item. The auctioneer discloses the provisional winning bid and each clock round, and the auction moves to the next clock round. So it moves from one clock round to the next clock round, the next clock round, and so on, and therefore it is called as multiple round, right? There are multiple rounds which are in place, and the auction comes to a stop until no bids are received, right? That's when the auction starts, right? Stops, right? And for example, the Poland auction that we discussed before, it went on for 180 days or something like that, right? It is quite possible that when the bids are coming, the auction can continue across multiple rounds. And it is an ascending auction because the price is always on the ascending. Price always increases and not decreases, and therefore it is called as ascending auction. So in particular, we will be talking about the simultaneous multiple round ascending auction, which was actually invented by Professor Milgrom at Stanford University, and it was first used in 1994 in the US, right? In India, we started using it from 2010 onwards, right? Most of the European countries also started using it from 3G auction around 2000, right? So that's the time frame that we are looking at. And the winner is declared at the end of the last clock round when no bids are received and they pay their bid price, and the item is allocated to that particular bidder, right? So this is a simple mechanism designed with simultaneous multiple round ascending auction. Okay. Now, SMRA, as I discussed before, the simultaneous multiple round ascending auction. In this particular study, we only focus on SMRA, right? So this is a way to control, for example, that type of mechanism design so that we can compare the spectrum prices, the winning bid prices across different countries, across different bands, and so on, right? So we control for this, so which means that we only study in this particular talk on the behavior of the simultaneous multiple round ascending auction. Right? Now, if you look at the simultaneous multiple round ascending auction, now I mean the reason is also that SMRA has become really a standard, and most of the countries have been using it for quite some time, right? And therefore there is a huge database which is available for us to analyze. Right? So if you look at the movement of the spectrum prices across the world, you see here the median price of sub-gigahertz is somewhere here, mid-band is somewhere here, and the high frequency band is somewhere here, right? This is actually the sub-gigahertz band. This is sub-gigahertz, and these are mid and high band. High band, that is mid band is about 1 to 5 gigahertz, and this one is greater than 5 gigahertz. This one is less than 1 gigahertz. And you see here that the sub-gigahertz band in general are priced much higher compared to, for example, the mid and high band. If you see here, this is the unit which we will use throughout this particular discussion, and that is the winning bid price in international dollars, right? International dollars adjusted for purchasing power parity per megahertz per capita, right? It's per megahertz per population, right? So you see here that approximately we are talking about $1 to $3 per megahertz per capita of the price for the sub-gigahertz band, and almost $1 to $2 for mid and high band. That's the spectrum prices, movement of spectrum prices in the world over a period of time. Okay. So we'll just take you through the country snapshot, because this is a cross-country study, and therefore we will take you through some of the country snapshots. Now, the one which is very, very interesting and very complex is the US spectrum auction, right? Now, US started the spectrum auction in 1994, for a block size of 50 kilohertz. 50 kilohertz is nothing but a very, very tiny amount like this, right? But in 1994, that itself was quite a precious item for the bidders to bid for, right? And in fact, Professor Milgrom advised US Federal Communication to go for a simultaneous multiple round ascending auction for the 900 megahertz PCS band, the Personal Communication Systems band. In fact, it fetched, at that time, about $27 million to the US Federal Communication Commission. Subsequent to that, there were a lot of auctions which were conducted, right? Almost every year. I mean, you see across bands, right? 700 megahertz, and you have 900 megahertz, 1900 megahertz, which is very unique, very, very unique to the US, 1700 megahertz, again unique to the US, 2100 megahertz, 24, 28, and 31 gigahertz, right? Which is a high frequency band over a period of time, right? And one of the very important auction was auction 73 for the 700 megahertz band, which happened sometime around 2008. Now, if you see here, there are a lot of dots, right? So which means that the items which are put on sale was huge, large number of items that were put on sale, right? Only for this particular band. The reason was that the US is divided into very, very small cellular service areas, right? The whole country is divided into so many cellular service areas, close to about 700 to 800 cellular service areas. And the radio spectrum is allocated for each of those cellular service areas in the 700 megahertz band in auction 73, right? But if you see here, the average comes out to be approximately about $1 international dollar per megahertz per population, right? So this is so US auction is very, very interesting, but it's also very complex because the auction is held over many service areas simultaneously, right? And it can happen across bands. And therefore, we treat the US spectrum auction a little bit differently in the subsequent sections. Then in Europe, right? The Europe, the success of the auction was in 2000 when 3G spectrum in the 2100 megahertz band was auctioned. And as you see here, Germany, Netherlands, Italy, Switzerland, they all auctioned spectrum using simultaneous multiple round ascending auction procedure. Now, if you see here, the median price of the 1800 megahertz band and 2100 megahertz band that you can see here, it's 2100 megahertz is about $1.5, and the 1800 megahertz is about $0.5, and that's roughly the way in which the spectrum was sold in Europe. In fact, I'll show you a little bit later. There are a lot of 5G auctions which are going on in Europe across 3.3 gigahertz and 26 gigahertz as well, right? So, but in general, if you look at Europe, the price is hovering around $1 for the 2100 megahertz, and about $1.5 to $2 for the 1800 megahertz, right? So that's the way in which it has been, the price has been moving in Europe. In India, we started simultaneous multiple round ascending auction in 2010. It was the first SMRA auction which took place for the allocation of 2100 megahertz and 2300 megahertz, right? 2100 megahertz for 3G and 2300 megahertz for broadband wireless access service. And this is paired band. That means that there is a frequency pair which is given to the winning bidder, one for communicating from the mobile handset to the base station, and the other from base station to mobile handset. Whereas for the broadband wireless access, we basically auction unpaired band, right, using time division multiplexing. Total swat of band is given, not paired. Right? Now the auction was quite successful, I must say, that it went on for 34 days, right? 183 rounds, and then yielded about $16 billion to the government. Thereafter, SMRA auction for different bands has been held from 2012 to 2016 every year, and the last one was held on February 2021. Right now, if you look at the movement of the spectrum prices, there's not much surprise, but the surprise comes later. I'll tell you. But in general, the sub-gigahertz band hovers around $1, and the high frequency band hover around $0.5 to $0.6 per megahertz per population, right? So that is the way in which in India the spectrum prices have been moving. There are also 5G auctions. In fact, we have not totally analyzed, but some of the IIM Tech students are with me, and also with Professor Rohit Prasad, in order to find out what is happening in 5G auctions. Now, as I told you before, their preferred bands for 5G is across, right? For example, even in the 700 megahertz, which has superior propagation characteristics, you can provide 5G. But if you look at 5G, except for some outliers, the spectrum price hovers around $0.5 per megahertz per population. For 3.3 gigahertz, the high frequency band, I mean the mid band, the price is hovering around $0.15 US dollar per megahertz per population, right? So that's the general trend that we see in the 5G auctions which are being held in Europe as we speak. So having got the snapshot of the way in which the spectrum price movements are happening across countries, let us look at what we want to delve into, right? So the model. So and before that, we need to position our work, right? Because a lot of work has already been carried out on spectrum auctions. So what we try to do is that we want to find out the movement of spectrum prices, and we want to keep the mechanism designed as a control variable, which means that we will only look at SMRA, because we cannot really compare SMRA with packaged auction or SMRA with clock round auction and so on, right? Therefore, to fix our mechanism designed to SMRA, we cover large number of countries and large number of auctions which have taken place, right? Now, we also cover US auctions separately, because US auctions are quite complex and there are many service areas, right? We cover India auctions separately, because India auction is also happens across service areas. There are about 22 service areas, and there are some unique challenges to conducting India auctions, right? We'll come back and discuss about this in more detail. But in otherwise, we basically study across all countries, right? So there are regional auctions. We study regional auctions are basically US and India. And then for all the other countries which are small in nature, we only cover the national auctions, right? National auctions happen across the country. In fact, the US also held some national auctions. The Australia and Canada, they have also held national auctions. Not the national auctions were not held. Only in India that we did not have a national auction. Okay? Now, to position your work, a lot of studies have been done on US auctions, obviously, right? So, for example, even Professor Milgrom has written many papers on US auctions. Europe auctions, Madden is the researcher who has explored quite a bit about the 3G auctions. Some of the auctions, some of the 3G auctions, as you probably have heard, they're failures, right? So he analyzed them very beautifully, Madden. India auctions, of course, have give our names, Prasad and Sridhar. We have done that in the Spectrum auction book, Spectrum book. And country-specific auctions have also been done. But the cross-country study, right? So, for example, these country-specific studies are specifically on Germany, Poland, Finland, and so on and so on. They're all very, very country-specific. A cross-country study that is looking at across the auctions across all the countries. There was a very few number of studies, and one is by Tideman way back in 2010, limited data sets. And therefore, we want to position our study in this particular space, right? So we want to conduct a cross-country study of all the spectrum auctions which have taken place using SMRA as a mechanism, and then we want to position our research in this particular landscape, right? So that's the positioning of our work. So we do an empirical analysis, right, using the large data set of spectrum auctions which have taken place since 1994, the first US auction, until 2019. In fact, the new data set is expected to come, and we will, of course, write another paper for 5G auctions, which have been happening now. We use large data set. We use empirical analysis, and we basically it is geography wise, right? National for the US and India, and regional, regional for US and India, and then the national cross-country study. We use different kinds of regression models using pooled OLS and then fixed effect, right? And we will come and discuss about these methodologies later. Okay, now it's an interesting question, right? What does the spectrum, the winning bid price of each of the auction, depend on? What are the attributes that define, for example, or that dictate how much the spectrum price is in each and every auction? So broadly, we classify the determinants of the spectrum price according to these categories: the auction and technology attributes, consumer demand, and the telecom industry, right? And the industry variables. So in the case of technology and auction attributes, there are many auction attributes. They are very specific to auctions. For example, the reserve price. We'll discuss a little bit about the reserve price later on. How much of spectrum has been put into auction, right? The more spectrum that is put into auction, you see more of supply, less of demand, and therefore a negative causation between negative impact on the spectrum price. License duration. For how many years has the spectrum been licensed, right? So the larger the license duration. For example, in India, normally we give it for 20 years. In the US, it's 15 years. Many different countries use less than 15 years as well. Now, if the license duration is more, then the bidders have clear visibility on how to use the spectrum, and therefore you expect the spectrum price to be, you expect the impact of the spectrum price to be positive, right? Number of bidders participating in the particular auction. Obviously, more the number of bidders, more is the competition, and therefore it will have a positive impact on the spectrum price, right? So more the number of bidders, more will be competition, more will be the demand, and therefore more will be the spectrum price. Mobile density. Now, what is the mobile density in the country at this particular point in time? I mean, it can have ambiguous results. For example, if you have covered everyone in the country, then you don't need any spectrum, and therefore the demand will be less, and therefore it will have a negative impact on the spectrum price. On the other hand, if everybody, even if everybody is connected, if everybody is using very extensively, right, like 4G, 5G applications, video streaming, and so on, then there is a huge demand, and therefore it can impact the spectrum price positive, right? So we don't know exactly what the direction of this impact is. Then you have income. Of course, you expect more income. Countries will be able to consume telecom services quite a bit, and therefore there will be a demand on the mobile services, broadband services, and therefore the spectrum, and therefore the impact on the spectrum will be positive. Population covered. More the population, more will be the demand, and more will be the spectrum price, right? And telecom investment. How much is the investment that is being made by the operators in the telecom industry. Telecom. So, for example, spectrum is just one part, right? So they have to provide access network, radio access network, as previous speakers talked in this particular series. There has to be a backhaul connectivity and so on and so on. There is a whole lot of telecom investment that needs to be made, right? Now, economists have divided over the impact of telecom investment on spectrum prices. For example, they say that spectrum price, once it is paid, is a sunk cost, and therefore further telecom investment should not be affected. Whereas some say that telecom investment will have negative effect of the spectrum price. So we don't know exactly what the orientation of this particular attribute is on the spectrum price. So basically, these are all from mostly from everything is from literature, and we have taken some of these data from the .econ database, which has all the spectrum or auction technology related attributes. We take this telecom industry from the ITU database. This is from .econ, and the consumer demand, GDP per capita, and things like that from World Development Indicators. So we have many data sets by which we have compiled this particular data. And in general, we're going to basically run this particular model, right? The price, the winning bid price of, IJT, right? So IT is for time period, and I is for a country, and J is for the frequency, because as we know, the spectrum prices for different frequencies can be different in the same, and therefore this is the basic model that we plan to estimate. Okay. So importantly, this particular data set that we have is a panel data set, right? So which means that we have across all countries, we have across all bands, and also we have a time series, right? So this is a good panel, right? We not only have time series data, but we also have the panel data across countries and across spectrum band, right? And therefore, it is a good data set to analyze. And of course, the basic model that we will fit is the ordinary least square method. But since it is panel data, we will also explore fixed effect models, right? What is a fixed effect model? Fixed effect models are those in which there are group-specific intercepts to account for heterogeneity amongst the group members. So, for example, if you take the country as a group, right? And then you have many countries, right? For example, Germany, not India, so Slovenia, and then Australia, Canada, and so on. So it is quite possible that there can be heterogeneity, right, amongst these countries, and that may influence the spectrum price. Obviously, there are heterogeneities among countries, and therefore the fixed effect models allow us to explore the country group specific intercepts, right? So, for example, there is an intercept for G, there is an intercept for A, there's an intercept for C, there's an intercept for S, and so on, and to account for the heterogeneity among the group members. Similarly, there can be heterogeneity across J. For example, there are 700 megahertz, 800 megahertz, 2100 megahertz, and so on and so on. So there can be inherent characteristics which affect the spectrum prices. In fact, as telecom engineers would know, the sub-gigahertz band, right, 700, 800, 900 megahertz, are sometimes called as golden band because they have superior propagation characteristics. They can travel over large regions, and their indoor penetration is quite good, right? Indoor penetration, you must have felt it. For example, RGO works much better than, for example, Airtel or Vodafone, because RGO operates on the 800 megahertz band, right? And therefore, there are inherent characteristics that are specific across within that particular group. And therefore, if you do a band-specific intercept, then that will account for the heterogeneity amongst the group members. And hence, the fixed effect model is a good way to analyze the panel data compared to, for example, the ordinary least square method, right? Of course, we use something called as least square dummy variable method, because once you have these intercepts, there has to be a dummy variable, right? So normally the dummy variables will be I minus 1, or J minus 1 dummy variables will be included to account for the country, the group specific intercepts in the regression models. So we use both fixed effect as well as the OLS in order to find out how the auctions are taking place across the country, and what are the determinants of the spectrum prices. So if you look at this particular national auction, first we'll consider national auctions, that is auctions in which the spectrum band is available for use throughout the country, right? So for example, it is more so in the case of European countries and Middle East and some of the Asian countries like Korea, Japan, and Philippines, and so on and so on, right? All those are very small countries, and therefore normally the auctions are national in nature, right? Now, if you look at the analysis, we have pooled OLS as well as the fixed effect, and the fixed effect can be on group specific attributes such as country, and this is for I, this is for year T, and this is for the frequency band, right? There can be country specific intercepts. So we run these fixed effect models with country specific intercepts as well as the pooled OLS. Now, one thing that I want to point out is that across all these, right, if you look at all these are all the coefficients, they are significant, as you can see. Now, across all this, you can find out that the reserve price stands out, right? So the reserve price in all these places is, these are very highly significant and have significant positive coefficients associated with it, right? So which means the reserve price is clearly a determinant of the spectrum price, and it affects these winning bid price positively. Now we need to understand what is reserve price, right? So we need to understand what is reserve price. Now, when the simultaneous multiple round ascending auction takes place, in the first clock round, that is sorry, in the starting round, the minimum price for each of the item is fixed, and this minimum price is known as the reserve price, right? So every bidder has to at least pay this minimum, at least bid for this minimum price or higher. Now, if they don't bid for any of the items in the first round, then they are automatically kicked out of this particular auction, right? So this reserve price is the minimum price, the first clock round, simultaneous multiple round ascending auction. Now, this is actually auction variable which is set by the auctioneer, right? It is set by the auctioneer, and therefore we will discuss more about reserve price, right? But in general, as you can see, that reserve price plays a major role in the winning bid price of the auctions. Now, apart from that, the number of bidders also is significant, and it is positive. So as the number of bidders increase, there is a high competition, and therefore it has a positive impact on the spectrum price. The available spectrum has the negative coefficient and is significant, relatively significant, which means that when the available spectrum, the spectrum that is put on sale, is larger in quantity, then it increases the supply, and therefore the price is expected to fall, right? So this is the analysis of the national auction which takes place. Now, we also analyze the US auction, right? US auction is quite involved, as you can see here. It's a huge data set because these auctions are held for the cellular areas, which are quite large in number in the US across different bands, and they have been having it since 1994. But again, we run both the pooled OLS as well as the fixed effect model. And you see here again, the reserve price stands out, right? In fact, the coefficients of the reserve price much higher compared to the national auction, which we have seen, right? But it has a positive impact on the spectrum bid price, winning bid price. And the same thing holds good for example, number of bidders, as you can see, right? And the population also has a significant effect, as you can see here. Now, as the population covered, it is very important in the case of regional auctions, as in the US, because you have a cellular mobile service area, CMSA, cellular metropolitan statistical area. And if this area, for example, in Boston, you have large number of people living in this area, and therefore this increases demand compared to, for example, Iowa City, where I studied, where the number of people are very minuscule, and therefore the demand for spectrum in these particular areas is expected to be less, right? And therefore the population has a significant positive effect on the spectrum price, right? This is about the US auction. We also analyzed all the India auctions, which took place since 2010 until 2016. We did not analyze the 2021 because the data was not available at that time. And if you look at it again, the reserve price, and again, a huge, not as much as in the US, but a huge coefficient, which indicates that the reserve price influences the winning bid price. And as usual, the number of bidders has a positive effect on the winning bid price, and the available spectrum has a negative impact on the spectrum price, as we have hypothesized earlier. Right. So if you look at the descriptive statistics, you can see here that the mean spectrum price in India is more than $1, right? Even the median is about 0.5 or something like that. And the available spectrum, if you compare it with the previous case, the US auction, is minuscule, right? In the US auction, the available spectrum is in 10,000 megahertz range, whereas in India, it is all in um, if you see the available spectrum, it's all in thousands, right? So 10 times less compared to, for example, the US, right? So there are a lot of implications for this, and this is the summary of the analysis that we have done on the spectrum database. Now, what does it all mean, right? That's the most important thing. What does it all mean? What are the policy implications for this? So from the analysis, we can basically conclude that the reserve price, right, that is the price, the minimum price that is set the first block round simultaneous multiple choice ascending auction, is one of the important factors affecting positively the winning bid price in the spectrum auction. We also see that the available spectrum, right? If there is more available spectrum, then the spectrum price reduces. So I'm not saying that spectrum price should reduce, because if the spectrum price reduces, that it means less revenue for the government exchequer. But the regulators have to shift the usage of spectrum from unused and underused areas to one that yields maximum societal benefits, right? So which means that we will discuss later on about how in India the spectrum is assigned, right? There's a lot of spectrum which is unused and underused, and it has not been released for commercial mobile services, where it is overused, right? And therefore there has to be an equitable allocation of spectrum across different users. Adequate competition, that is very, very important, right? In India, as you probably know, there were 8 to 10 operators per licensed service area in 2000 until 2015, right? Today, the number of operators have reduced to 2 to 3, right? With for example, with BSNL and Airtel and Vodafone India almost on the verge of going out, and RGO as the sole operators, and therefore only these 3 or 4 will bid, and less is the competition. There is less, there is a negative impact on the spectrum prices. It's not good for the government, right? Because government wants to maximize the use and value of the scarce resource. Right? So these are all important implications with respect to policy, and we'll come back and discuss. Okay, so what is the reserve price and its impact, right? Now, reserve price is the minimum price to be paid by the bidder for the item and set in the first block round, right? Now, how to set and how much to set is a policy dilemma, right? Because we don't know. If you set a very high reserve price, then it is quite possible the item may remain unsold, which happened in India in 2016 and 2021 for the 700 megahertz band, right? Now, if sold, I mean, in case it gets sold, if you fix a high reserve price, then it yields high revenue for the auctioneer, right? On the other hand, if it is just set too low, right, then it might actually, the winning bid price, because it positively affects the winning bid price. If it is low, then winning bid price is expected to be lower, and it might reduce the revenue for the auctioneer, right? So the auctioneer is always in a dilemma whether to set the reserve price high, right? In which case it might remain unsold, or if it is sold, it can earn a lot of revenue for the auctioneer. It can, if it is set low, then it might reduce the revenue for the auctioneer. So it is the temptation of the auctioneer to always fix a high reserve price, right? And how is it set? Normally set based upon historical data, right? So look at what happened in the previous auctions and then set it. In fact, in India, the reserve price is set based upon the previous winning bid price, right? So this is the way in which the reserve price is fixed. So for example, in 2021 auction, we fixed the reserve price based upon the winning bid price of the 2016 auction for that particular band, right? Because this is one of the historical data that we have, and therefore we want to do better as an auctioneer. The auctioneer wants to earn more revenue, and therefore he fixes the reserve price based on the winning bid price, right? Now, this is basically, it haunts regulators worldwide, and that is a very important discussion that we need to have, right? So how to fix the reserve price? Should we set it high, or should we set it low, or should we set it based upon historical data? Should we set it based upon international averages? It's a question that haunts the regulators, right? So let us look at reserve prices in India. Okay? The average reserve price fixed by the government of India for 700 megahertz in the recently concluded February 2021 auction is $1.89 per megahertz per population, right? It is several times higher than set internationally. The international reserve price on the average is about $0.05, right? It is multiple times compared to the international average. In fact, the winning bid price, the international average for 700 megahertz worldwide, is just 0.54. So which means that we are fixing the reserve price, right, which is equivalent to some 3 times the winning bid price in all the other countries, right? In all the other countries. And therefore, this is huge difference in the reserve price that India government is fixing on the 700. Let's just talk about 700, right? If you look at it very closely, as I've discussed previously, in India we have 22 service areas, and most of them are states, except that we have 3 metros, right? 3 metros. It is Delhi, Kolkata, and Mumbai. The reserve price in metros is set at $8.72, right? Whereas 0.5 and whereas $8.72 is several times higher than the mean bidding price in many of the other countries. Only this particular average comes out to be 0.52 only for category C circles. Category C circles are circles like Bihar, Assam, Odisha, Northeast, right? So all these telecom circles are called category C circles, and category C circles is a reserve price which is set at 0.53, which is close to the international winning bid price, right? So obviously the reserve price in India is very high. Now it's not only for 700 megahertz. In fact, the TRAI is recommended a mean reserve price for the mid band at 0.28, which is 14 times more than the average reserve price worldwide of 0.02, right? So at metros, the reserve price for the mid band, that is 1800 megahertz, 2100 megahertz, is very high at $1.3, when the mean reserve price worldwide is 4.02, right? So which means that we have a very high, we have the that is one of the reasons why, for example, the 700 megahertz, because of the high reserve prices, nobody wants to take a chance and bid and become bankrupt, right? That is one of the reasons why 700 megahertz went unsold in the 2021 auction. In fact, it went unsold in the previous 2016 auction. We repeated the same mistake in 2021, and we lost the golden opportunity to actually sell the 700 megahertz for ubiquitous connection. So that's the story of the reserve price, right? Now, what about availability of spectrum? Most countries, the government holds major portion of the radio spectrum. Now, for example, in the UK, for instance, the defense accounts for 75% of the public sector spectrum, right? In the US, 700 megahertz. 700 megahertz, it was a huge problem because it was interfering with the traditional TV broadcasting, because traditional TV broadcasting over the air still exists in the US, and therefore the US invented a very unique method of auctioning the spectrum in the broadcast brand of 600, 700 megahertz using incentive auction. We'll not go into the details. In India, the 3.3, 3.6 gigahertz spectrum, right, which has been expected to be auctioned soon, which was not auctioned in February 2021. It interferes with the satellite downlink frequencies, INSAT satellite downlink frequencies of the Department of Space. So there is still some ambiguity as to whether this 3.3 to 3.6 gigahertz, which is very much required for 5G in India, will be released soon for commercial mobile services. In fact, the traditional 1800 megahertz band was just recently reformed from the defense use, because defense was using most of the 1800 megahertz for its own purposes, and therefore it has been reformed only. So which means that we have a lot of spectrum which is owned by the government for sectors like defense, Department of Space, utilities, Indian Railways, and so on. And these we have to have a relook at it. Defense spectrum has been relooked at it, thankfully, especially in the 1800 megahertz band. 3.3, 3.6 is still ambiguous whether we are going to release it or not, and therefore we need to release some of these unused or underused spectrum for commercial mobile services, so that it will have some impact on the spectrum prices. So in fact, if you go back to US auction 96 in 2014, a total of 1760 megahertz were put on block, right, for auction. The same year 2014, India put 862 megahertz, right? So 1760, so it's almost half is what we have put in auction in 2014. Now, recently in the US made available almost 15,000 megahertz of spectrum between 2010 and 2016, whereas India, between the same period, auctioned only 1,500 megahertz, 1/10 of that auction in the US. So which means that we have severe restriction on the availability of spectrum for commercial mobile services, right? Now, so the available spectrum in the spectrum auctions is very less, and therefore it can increase the spectrum prices. And you know what? The higher spectrum prices necessitates the operators to pay out, right? And obviously, the operators will try to milk the customers like you and me for getting revenue so that they can pay the government exchequer whatever they have bid for. So which means that the mean price of our telecom services is expected to increase. Now you can ask this question, why is it not increasing and it is decreasing? And thanks to RGO, right? So that's a different matter altogether, right? About competition. Now, the important thing is there is also something called as unlicensed spectrum, right? So in fact, our Wi-Fi works on unlicensed spectrum. And is it possible that there is a complementarity or substitutability between licensed and unlicensed spectrum? So in fact, the unlicensed spectrum can complement the licensed spectrum bands. Specifically, we look at B band, which is 60 gigahertz spectrum, 57 to 71 gigahertz. It provides high capacity point-to-point as well as point to multi-point connectivity, and it can be used for fixed wireless as well as for backhaul. And IEEE 802.11 AD and AY have unlicensed this particular band for giga Wi-Fi, right? Now, most of the countries like Australia, Belgium, Poland, and so on, China, Korea, Australia, New Zealand, US, everyone has unlicensed the B band, right? The 60 gigahertz band to be used for gigabit Wi-Fi. India is yet to do it, right? In fact, in India, this 64 to 71 gigahertz is used for backhaul. In fact, we the Telecom Regulatory Authority of India recommended delicensing 57 to 64. I and Rohit have written many articles in the newspapers asking for 57 to 64 gigahertz to be delicensed for Wi-Fi and gigabit Wi-Fi, and 64 to 71 to be used for a licensed mode for backhaul. But still talks in progress, and no progress has been made with respect to releasing 60 gigahertz band for unlicensed operation, right? So if it is unlicensed, obviously the load on the licensed spectrum will come down and will have impact on the spectrum prices as well. So I'm almost coming to an end. It's almost one hour, and there are a lot of limitations to our research. We don't say that our research has, it has provided a new way of looking at spectrum prices across the countries. But today, the simple SMRA is no longer used. SMRA with augmented switching, with various nuances that have been proposed by Milgrom to minimize the effect of undue increase or decrease in spectrum prices or being used. More countries apart from the US have started using packaged auction and combinatorial clock auction. In the package of, for example, as we speak, a lot of 5G auctions in the 700 megahertz, 3.3 gigahertz, and 26 gigahertz are taking place in Europe, and these are bundled, right? So you have a package of items. So you can buy a package consisting of 700 plus 3.3 plus 26, and not individually, right? And that's known as packaged auction. So most of the countries have shifted towards package auction, especially in case of 5G. We are in fact we will be looking more closely at 5G auctions in our next topic as our next topic of research. The 60 gigahertz B band, how whether to unlicense, license, how it's going to be implementable is a question mark, because this is a band for 5G, right? It's a crucial band for 5G, and therefore the decision to unlicense will definitely help pick up 5G in our country as well as in other countries, right? There is also 6 gigahertz band, which is an unlicensed band, which is being used by Wi-Fi 6. We also have to look at the complementarity and substitutability of licensed and unlicensed band to 6 gigahertz. In fact, I have heard recently that we have started working on 6 gigahertz for Wi-Fi 6 and planning to de-license it, right? That will definitely help, complement Wi-Fi with, picocell access and so on. So that's more or less what we have to share in this particular research. Now, I have to point out that this particular paper, based upon the cross-country analysis, is available in the electronic form, and it's published in the Journal of Telecommunications Policy. I must point out this particular note, right? This is the Parliamentary Standing Committee on Information Technology on February 8, 2021, just before the auction took place, recommended that the Department of Telecommunication and the Telecom Regulatory Authority of India look into high spectrum prices and come out with spectrum pricing policy that is sustainable, affordable, and acceptable to all, right? So there is a directive, but unfortunately we went ahead in the auction towards the end of February 2021 with high reserve price, especially for 700 megahertz, which remains unsold, right? So we need to really look at how to set reserve price, how to make more spectrum available, how to increase competition in the upcoming forthcoming auctions. So that's about it. Over to you, Arvind, for any questions. And Professor Rohit Prasad is also there. He can also answer some of the questions.
Thank you, Professor Sridhar. Now the floor is open for questions.
Can I ask a question to Professor Sridhar?
Yes, please. Go ahead.
Professor Sridhar, thank you. Very wonderful talk.
Yes,
and it's very knowledgeable about the spectrum across the globe and its auction and its impact and all. So I have two questions. Question number one is that why Indian government, that's a difficult matter in the sense you and me as a researcher, fixed to that reserve price so high, because they used, when I said that it didn't went ahead for the auction. So what was the problem? That was the why they kept so many times thinking that they will get the money from the operator. What was the philosophy behind? Any literature available?
Yes, sir. Sir, literature is available in our book. But anyway, I mean, it's not a joke. So your point is very valid, right? The important thing is in 2011, as you probably are aware, there was this Controller Auditor General of India came out with a report saying that the spectrum in India is not priced accordingly, right? We were in fact using 2001 winning bid price for most of the allocation of spectrum between 2001 and 2010, right? And therefore 2011, the biggest scandal of all the times, 2G scam happened, right? So so the Supreme Court in 2012 in its landmark decision said that all the scarce resources, right, including spectrum, should henceforth be auctioned, right?
Okay.
Now, from that moment onwards, we followed the auction route. There's no problem, right? But there was always a fear. It is public, it is going public, but I am willing to say that there is always a fear in the government that, if you reduce the reserve price, then the government exchequer will lose revenue, because the reduced reserve price will translate into lesser revenue for the government. And therefore, excessive governments have always increased the reserve price. They never dare to reduce the reserve price, right? One, because of the things that happened in 2011, and also because of the Supreme Court decision, right? And how do we fix the reserve price? The only benchmark that they had was look at the previous winning bid price, right? And therefore, mark up 10%, 15%, 20% more and fix that at the reserve price, right? So this fixing of the reserve price was not very, very scientific, right? It was based upon the previous winning bid price. And that is one of the reasons why we kept on increasing the reserve price. And the winning bid price, it was always increasing because we had less spectrum put on auction, and therefore that increased the spectrum winning bid price for that particular band. And therefore it never decreased at any point in time. Rohit, does that answer your question, sir?
Yes, Professor Sridhar, this is Das here. So answer your question. Thank you very much. Yeah. So now my second question is, quickly, I will not take much time. You see, if I remember, correct me, the year 2010, government auctioned the 4G spectrums.
Correct.
Okay. But in India, the 4G deployment started happening in 2014-15. That is the operators started.
Correct.
So, but the 2010, the auction happened, they must have paid the money to the government.
Correct.
Okay, so how this 4 years of gap, so much money they paid to the government, but they didn't roll out the 4G. How these operators play this juggle, means so much of lakhs of crores of money they give to the government, but they're not rolling out the 4G. So
correct.
Manage that such much.
Correct. Absolutely. Your point is very valid, sir. So in 2010, we had two auctions, right? So one is for the 2100 megahertz for the 3G and 2300 megahertz for the broadband wireless access. Right?
Yeah.
So normally when the auctions take place, there is something called as rollout obligations, which the operators have to fulfill, right? Within first year, second year, third year, and so on. Right? So that the spectrum which is auctioned is put into good use and it is not wasted, right? Nobody hoards the spectrum.
Okay.
No, when we did this, the broadband wireless access, we basically meant internet services, right? And therefore we relaxed the rollout conditions. The rollout conditions was not 3 years, but for 5 years with lesser rollout obligations compared to, for example, 3G, 2100 megahertz. So the operators who got 2100 megahertz, normal telecom operators like Vodafone, Airtel, they had to comply with the rollout obligations very strictly compared to the bidders who got the 2300 megahertz, right? Such as Reliance Communication and some parts in India by Aircel. So these operators did not have a strict rollout obligations and therefore they escaped not putting in any telecom infrastructure for 4 years.
Okay. Thank you, Professor Sridhar, for your wonderful talk.
Yes, Professor Das, thank you.
Over to the host. Thank you.
Arvind?
So there is one question in chat. There's a question, how to bring more players into the auction?
Rohit, are you there? You want to take this question?
Yeah. One way of bringing more players into the auction is to, according to theory, is to reduce the reserve price. But I think in the context of telecommunications, bringing more players into the spectrum auction is really a matter of making sure that the business environment is healthy for the telecommunications licensees in the country. And that really has been a problem that the telecommunications sector has been facing. There has been a fair amount of coverage of some of the issues. For example, the issues regarding the AGR, the adjusted gross revenue, the dues with regard to AGR, the rules with regard to bankruptcy, whether the government dues need to be settled before the dues of the financial creditors. So there are a number of issues as a result of which the telecommunications sector in India is bleeding. And the only way to increase bidders is to actually ensure that we make some changes in the business environment of telecommunications in the country. So that's a generic answer, but I think that is the truth, broadly speaking.
Thanks, Rohit. Are there any other questions, Arvind, on the chat?
Yes, there's one more question by Professor Amit Prakash. So do you also consider profitability of the telecom firms and its relation with the price at which they had procured the spectrum license?
I can take that, Sridhar. I can.
Yeah, go ahead, go ahead.
There are two schools of thought on this. One school of thought, which really is comes from classical economists like David Ricardo, states that the the that the profitability of the telecommunications operator is affected is not so okay, let me just organize my thoughts. So one school of thought says that the spectrum price is affected by profitability. So if you have higher profitability, there should be higher spectrum price. And if you have lower profitability, you should have lower spectrum price. That's one school of thought. And the other school of thought says that that the spectrum price and profitability are unrelated to each other. That basically the spectrum and the other inputs into production, like base transceiver stations, BTSs, etc., they are part of a process of cost minimization and profit optimization. And therefore, these things are simultaneously determined, and you cannot say that there is that first, we determine what is the profitability of the company, and based on that, we arrive at the spectrum price. So there are both schools are valid. I'm sorry, I'm not as clear as I would like to, but I'll just give you an example of a practical application of these two schools of thought. So if you were to say that that the spectrum price depends on profitability, then in order to arrive at a spectrum value, at a value of spectrum, what you would do is you would try to see what are the cash flows that would be generated, or the free cash flows which would be generated through the operations of a telecommunications operator. And then those cash flows will determine what is the willingness of the operator to pay for spectrum. And so those cash flows will determine what is the spectrum price. Okay. On the other hand, if you believe that a spectrum was just like any other input and actually it determined profitability rather than its value being determined by profitability, what you would do is you would say that let's look at BTSs and spectrum as two substitute inputs. And we know the price of BTSs, and the price of spectrum will be determined in the process of cost minimization, right? Where we say the bang per buck for BTSs and spectrum should be equalized. And in that process, since we know the price of BTSs, we can arrive at a price of spectrum, right? So in this method, we are saying that it is not profitability which determines spectrum price, but actually spectrum price is determined in the process of optimizing profits. So that's basically, and both these methods have been used to come up with spectrum value. So the first method is in which we say the profitability determines spectrum price is associated with something known as the cash flow method for determining spectrum value. And the second method is determined with the allocative efficiency method of determining spectrum value. So sorry for a long-winded answer, but that's about it. Sridhar?
Yeah. So one more thing, Professor Amit Prakash, we also use telecom investment, right? In our analysis, the telecom investment is actually a net of the spectrum price that was paid, right? So which means that all the investment that is put on non-spectrum related assets. So maybe you can think of it as a proxy for profitability, because only the profits or surplus from the company is put into the telecom infrastructure. And this particular variable did not have any significant effect, right? And therefore, like as Rohit said, probably there is a dual causality or something like that that we should explore. But in general, it was not really significant, significantly affecting the spectrum price. Arvind?
Yes. So we have a question from Dibakar. Does setting previous final bid price as initial price for the next auction lead to advantage for certain players?
I am not sure whether it leads to advantages for certain players, because see, the objective of any auction, right, including the simultaneous multiple round ascending auction, is to extract the truthful bidding, right? That's the objective of any auction. So which means that if I value it at X, then I will bid for X and not for X minus 1 or X plus 1, right? So it is to extract always truthful bidding, and therefore, irrespective of whether it is based upon previous winning bid prices or set anew, the bidders will actually do some valuation calculation, and therefore the mechanism design should be robust enough to induce truthful bidding. So I don't think it will anyway be advantageous to certain incumbents or certain players.
Well, one thing which might happen, taking a little bit from, I think, where Dibakar is coming from, is that if reserve prices are high, it benefits deep pockets. So if the previous final bid price overestimates the price of spectrum which is currently being sold, as a result of which the current reserve price is an overestimate, then it is the deep pockets which can stay in the market. So, but yeah, and the new entrants, etc., will probably not be able to compete. But that is a short-term phenomenon. In the long term, as Sridhar was saying, everyone benefits with setting reserve prices which reflect true value.
Yeah. Any other questions?
So we don't have as of now questions on chat. So I would request any more questions can be asked by unmuting. So if by the till the time any more questions comes, if I may chip in with a question. So I was just wondering whether the use cases of the spectrum usage, whether they are commercial or maybe due to some national policies, are for social upliftment in sectors such as agriculture and education. Do these kind of policy decisions somehow affect the reserve price?
Yeah. So definitely, I mean, it can. For example, if the government thinks that 5G is going to be very, very important for all the sectors, right? Not only for the mobile sector, but it has implications for agriculture, healthcare, and so on and so on. Because as we know, 5G is not about just network connectivity, but it is expected to provide, ubiquitous services. So if it thinks that it will matter, then it is in the interest of the government to lower the reserve price, right? Especially for the 5G spectrum in the 3.3 gigahertz as well as 700 megahertz, 3.3 gigahertz as well as 26 gigahertz, right? But that is a political decision, right? So normally it is a political decision, and as I have pointed to Professor Das earlier, we have always, successive governments have always refrained from decreasing the reserve price. It requires courage to decrease the reserve price because it might affect, for example, the revenue to the exchequer, which no government wants to take a hit on, right? So, but it is high time that we relook at our reserve price policy and then set a lower reserve price if we want ubiquitous 5G connectivity, especially for 700 megahertz. The golden spectrum band has remained unused since 2016, right? Which means that we have wasted such a national resource just because of the fact that we wanted to have a higher reserve price and higher revenue for the government. I will go on record to say that unless we reduce the reserve price, the 700 megahertz, the golden band for providing ubiquitous connectivity, especially in the rural and remote areas of the country, will never take off.
Can I just step in with 2 points? One is that, I totally, Sridhar and I have the same view on reserve price, but we wanted to point out an interesting conundrum. There are political implications to reducing reserve price, as Sridhar mentioned when he referred to the 2011 report of the CAG. So one way to depoliticize the setting of reserve price is to hand it over to a neutral agency like TRAI. But of course, that the government is not willing to do because it would hand over a significant amount of power. So there's that conundrum there. As far as the use of spectrum for social purposes is concerned, one thing which I would like to point out is that India is divided into 23 or is it 22 now, circles or license service areas. And some of these service areas are predominantly rural. So in these areas, the spectrum prices are lower and the reserve prices are also lower.
Your point is very well. So because again, I mean, if you remember, I mentioned that the reserve price in the category C circles, which includes Bihar, Odisha, Assam, Northeast, which are predominantly rural, it is equivalent to the average winning bid price, right? I mean, it is much lower compared to, for example, the reserve price for metros like Delhi or Mumbai. That point is very valid.
Thank you, sir. Any other questions, please? Thank you, sir. So I would like to thank Professor Sridhar and Professor Rohit for the enlightening and engaging talk in today's Samvaad. Also, thanks to all the participants for the thoughtful and engaging discussions. So I would like to request Professor Jaya to take over.
And wonderful talk. Thank you, Arvind, for chairing the session. This marks an end to the theme on 5G and communications. And next week we will continue with the theme on education and technology we briefly started last week. But before we end, I'd like to invite Professor Amrita, who actually ideated this theme and pretty much ran with it. I would invite her to say a few words on the theme altogether. Thank you.
Thank you, Professor Jaya. I would again like to add on to the befitting praises to Professor Sridhar and Professor Rohit. I couldn't have imagined climax ending to this theme on roadmap to 5G and beyond communication, but because it did discuss something in detail, which is as basic as spectrum auctioning, but it is going to have a very everlasting impact to each of our lives. So with this, we also came to know that not only 5G and beyond is going to bring in a personalized flavor in terms of an enhanced experience of technology, but there is a lot of policy making and a lot of decision making which is involved in order to make this a reality, in order to make this fructify, and in order to enable this to be a part of our lives in future. So with this, I would like to thank all the speakers and all the session chairs who have taken their time off their busy schedules and have been a part of this invigorating session. And I look forward to very shortly announcing a roadmap to 6G and beyond communication in the coming years. Thank you once again. Thank you, everyone. Have a nice day.